Okay, now here we go. This is where the fraction work really begins. This is some very, 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 very important information. Now, there's all kinds of ways to simplify, but I'm going to use the easiest way that I know how to explain this. And I'm going to use something called the fundamental law of fractions. It's actually the backwards way. The fundamental law of fractions states if you multiply the numerator by a number, then you must multiply the denominator by that same number. Well, I'm going to use that same philosophy and say it with division. If you divide the numerator by a number, you must divide the denominator by that exact same number. Otherwise, you change the fraction. And I'll explain that as we do this example. 12 over 15. Now, I know my multiplication tables. I know 3 divides into 12, and I know 3 divides into 15. So what I'm going to do is I'm going to divide the numerator by 3 and the denominator by 3. The reason why this is allowed, if I put a little fraction line between those 3's, that's the same thing as 3 divided by 3, which is 1. And anything divided by 1 is the exact same number. So that's why you can do this, and that's why you have to do the same to the top as you do to the bottom. That holds true for division and multiplication. And then 12, you just do the division. 12 divided by 3 is 4, and 15 divided by 3 is 5. Now let me show you the way that actually was taught, and when you get the hang of this, feel free to do this. It's the same thing. We're just going to do the work in our heads. Once again, we know 3 divides into 12 and 3 divides into 15. 3 divides into 12 4 times. 3 divides into 15 5 times. There's your answer. Got that? We're marking it out and replacing it with what it is. So keeping that in mind, watch this. I'm not going to do any work with this 14 over 21 except crossing them out. Once again, I know my times tables. I know 7 divides into 14, 7 divides into 21. A little hint here. If you take 21 minus 14, that's your 7. The largest factor that can divide into these is that difference, so those two numbers. So 7 divides into 14 2 times, 7 divides into 21 3, and we're done. On this one, we're going to do the numbers first and the variables last, and I'm going to show you the real way to do it, and then I'm going to show you how to look at it and do it. Let's do the numbers. 34 and 21 and 20. What goes above 34 and 20? I know that 2 does. You can think about it. Really, all you gotta do is look at the factors of 20. The factors of 20 are not going to use a 1. Are 2, 4, 5, 10, 20. The largest number divides into 34. That also is a factor of 20. Is that 2? 2 goes in 34 17 times. 2 goes in 20 10 times. So once again, if you didn't catch that, I'm listing the factors of 20. 1 and 20, 2 and 10, 4 and 5. Out of all those numbers, only the 2 divides into 34. That's why I used the 2. So now we have 17 on top, 10 on the bottom. This is x squared. I'm not going to write it as x squared. I'm going to expand it. Exponent means multiply by itself. In this case, multiply 2 of those x's. This means there are 3 x's being multiplied. Now watch this. I'm just going to cancel. That x is going to cancel that x. That x is going to cancel that x. And it's going to leave that x on the bottom. So your answer is 17 over 10x. Now when you get the hang of that, you can actually do the work in your head and just think, these 2 x's up here are going to cancel 2 of these x's down here, leaving an x on the bottom. That's how I prefer to do it. That's how I recommend it. In fact, I think we should do one more of those, and let's just do a crazy one. Let's just make up one and just see how bad we can make it, and see how little work we can use to find the result. So let's use 35 x to the 7th y to the 12th over, well, I don't know, let's try 105 x to the 11th y cubed. Now believe it or not, once you get the hang of this, you're going to realize that the variables are the easiest part of this problem. Watch this. These 7 x's on top are going to cancel 7 these x's on the bottom, leaving 4 on the bottom. Can you see that? These 3 y's on the bottom are going to cancel 3 of these y's on top, and it's going to leave 9 on top. And if you can see that without having to write them all out, It's going to save you a whole lot of time and a lot of headaches also. Now look at 35 and 105. Let's see what we can determine. One number that we know for sure that divides in 35 and 105 is 5, because they both end in 5. So let's do that. Let's divide by 5 first. 5 goes into 35 7 times, and 5 goes into 105 21 times. 5 goes into 10 twice, 5 goes in 5 once. A little shortcut way to do that. But notice, the 7's on top, 21's on the bottom. That breaks down, that reduces further, because 7 goes in 7, 7 goes in 21. Let's just do that. 7 goes in 7 once, 7 goes in 21 3 times, and it leaves us with the 1 over 3. Now you do not have to put the 1 if you don't want to, but I am just showing you that there was a 1 left over with the numbers. Now what that means is 7 or 5 wasn't the largest number that divides into both of those. See, we used a 5 to get a 7, and then we used a 7 to get a 1. Actually, the largest number that divides in both 35 and 105 was 5 times 7, which is 35. Something you might want to keep in mind as you progress through your math studies with fractions. And now, one last topic to look at: equivalent fractions. Now, my number line example that I did previously was really good. Let's think about a ruler. Start at the 0. Let's count by halves. Now, if we cut these up as such, if you know anything about rulers, you know that this is a fourth. If we count by fourths, it's the same as 2 fourths, 3 fourths, and 4 fourths. What I'm trying to show you is that 2 fourths and 1/2 are the same thing. In fact, we can keep on going. 3 6, 4 8, 5 tenths, so on and so on. There's an infinite number of possible fractions that equal 1/2. Those are known as equivalent fractions. They have the exact same value, but they look different. They have the different denominators and different numerators. And this is going to come into play later on, but this is a really big deal, and we'll talk more about it later. But basically the ideal is, for example, to go from a 1/2 to a 5 tenths. To go from a 2 to a 10, you multiply 5 by 2. 5 times 2 is 10. Well, once you do the bottom, you do the top. 5 times 1 is 5. And that's what this means. Once you do the bottom, you do the top. Once you do the bottom, you do the top. It's only true for multiplication and for division. Now this question right here is an application of equivalent fractions. Let's see if we can find a couple ways to do these. Let's just take 4/7 and compare it to 12 over 36. I'm going to show you two ways to do a problem like this. It doesn't matter which way you do it, you'll get the same result. Now these aren't equal as far as how they look, but they could be equivalent as far as do they equal the same value. So one procedure is to reduce. This is one method. 4/7 won't reduce, but 12 over 36 will reduce. What goes in both 12 and 36? The largest number I know is a 6. And so 6 goes into 12 2 times, and 6 goes in 36 6 times. Well, I was wrong. There was a bigger number, a 12. But let's go ahead and let's reduce the 2 and the 6. See what I did? 6 actually wasn't the biggest. There was a bigger one, but that's okay, because the 2 and 6, we can reduce that. 2 goes in both of these. 2 goes in 2 once, 2 goes in 6 3 times. And as you can tell, 4/7 does not equal 1/3, so these fractions are not equivalent. Now there was another way. There's another way. And now I'm really kind of scared of showing this because some people think you can always do this. This is one of the very few applications where you can actually cross multiply. So don't make this a habit. What you can do is you basically are going to compare Chris to cross. So we're going to go Chris cross. So 4 times 36 is what you want to do for the Chris, and then you want to take 7 times 12 for the cross. Now 4 times 36 is 144. 7 times 12 is 84, and as you can tell, 184 does not equal 84. So that's another way to verify that it's not, these are not equivalent fractions. This little equals with the line through it means not equals to. Let's do a couple fractions that are equivalent so you can see what's going on. Let's do 2/5 with 8/20. Now, once again, 2/5 is reduced. 8/20, let's see if it reduces. What goes in both 8 and 20? 4. 4 goes in 8 2 times. 4 goes in 20 5 times. Does 2/5 equal 2/5? Yes, it does. So yes, those are equivalent. Let's do the other method right quickly. Let's just go crisscross. 2 times 20 is 40. 5 times 8 is 40. Those are equal? Yes. And we are done.